Boys and girls, flip geometry. Miss Robbins was going to do this video, but she chickened out at the last second, so she's rolling her eyes at me right now, actually. We're going to do 4-1, which is classifying triangles. We are in a brand new chapter all about triangles. After this lesson, you will be able to identify and classify triangles using their angle measures and their side measures. So we're going to go ahead and begin with the lesson. First, let's take a look at this triangle. What do we know about this triangle? We know that it has three sides. We know that it has three angles. We also know that it has three vertices. Those are the very basic things we know about triangles. Now, just a reminder how to name triangles. We use the little triangle notation and then name it using the 3 points, the names of the points. So this would be triangle ABC. Again, doesn't matter which order you write these letters as long as they are in order. You can call this one BCA or triangle CAB. These are all very good. Now, there are a lot of different ways to classify triangles, but we're going to take a look at classifying triangles by the measures of the angles. Okay, so if you have an acute angle or three of them, remember acute means if you have an acute angle, that means it measures less than 90 degrees. If all three of them are acute angles, then it's automatically an acute triangle. If all of the angles are congruent to each other, so you have three congruent acute angles, that type of triangle is called an equiangular triangle. Now, if one of your angles is an obtuse angle, remember an obtuse angle, and I'll write that down, is greater, it's got to be between 90 and 180 degrees. So the measure is more than 90 but less than 180 degrees. That's an obtuse angle. If one of your angles, and we could just tell just by looking at it that it's going to be this one right here, if one of your angles is an obtuse angle, then it's automatically an obtuse triangle. The last one, if we're looking at the angle measures and you see one right angle, it automatically makes the triangle a right triangle. So let's take a look at these two triangles and classify them as being acute, equiangular, obtuse, or right. So the first one to the left here, we've got a triangle with three angles and each of them are 60 degrees, which makes this an equiangular triangle. Some of you may say, hey, but all those angles are acute. Can it be acute as well? It can be acute, but more specifically, it's going to be equiangular. Now, the one here to the right, we've got an angle that measures 30, 20, and 130 degrees. Since we have an angle that is obtuse, remember, this automatically will be an obtuse triangle. Now let's classify these triangles as acute, equiangular, obtuse, or right. Let's go ahead and name the triangles that we have. And if you look at this figure, we've got 1, 2, and yes, there are 3 triangles in this figure. Let's go ahead and name them. First one I'm going to name is triangle XWY. XWY, and that's this guy right here, XWY. Okay. The next one we're going to take a look at is triangle WZY. WZY, and that of course is this guy here. Then the last guy we're going to look at is the big one, triangle XZY. Okay, which is that guy right there, the big one. So now let's take a closer look at these. We'll start with let's start with WZY, the one in the middle here. Okay, let's go ahead and highlight this guy again, WZY. Since it has a right angle here, that means it automatically is going to be a right triangle. So this one is going to be classified as a right triangle. Now, the one right above it, XWY, we can look at and say, since this here, remember this here, we just said it was a right angle. This one here will also be a right angle. Why? Because that's a straight line. And if this is 90, they make a linear pair, and if this is 90, this one's also going to be 90. So if this is a right angle, guess what? This triangle will also be a right triangle. then the big one. We'll take a look at the big one here. Let me highlight it for those of you that need me to. X, Z, Y. Let's take a look at the angle measures. We've got a 50-degree angle and a 40-degree angle. And if we add both of these together, 40 and 50 make 90. The sum of these two angles is a right angle. So again, this big one is also going to be a right triangle. All three of these triangles that we see here in this figure are right triangles. Now we're going to look at these triangles and classify them by the lengths of the sides, the measure of the sides. There's only three of these: equilateral, isosceles, and scalene. Equilateral triangle, of course, is when you have three congruent sides. All these three sides are congruent. It makes it an equilateral triangle. Isosceles triangle is when you have at least two congruent sides. These two sides here are congruent to each other, making this an isosceles triangle. The last one is a scalene triangle, which just means that none of the sides are equal to each other. They are not congruent at all. Three different side lengths. Now, the one question I have for you is an equilateral triangle an isosceles triangle? Many of you would probably say no to that question, but yes, it is, because of the fact that right at the beginning, or right under here, the definition of it says at least two congruent sides. Does this have two congruent sides? Yes, it does. It has at least two congruent sides, so it is an isosceles triangle. But more specifically, because it has three, it's an equilateral triangle. It's just something to make note of. Now this problem reads, if point Y is the midpoint of line segments VX and WY equals 3 units, classify triangle VWY as equilateral, isosceles, or scalene. We've got to look back at to see what it says at first. It says if point Y is the midpoint of VX. What does that mean? Now if you remember from before, if this is the midpoint, this is point Y, that means it bisects line segment VX. That means this is congruent to this side here. These two halves are congruent to each other. Now, it's asking us, it also told us that 3.0 is the measure for WY. Let's go ahead and mark that in the figure there, 3.0. And now it's asking us if triangle VWY, which is that one there, is equilateral, isosceles, or scalene. Well, if you take a look at it, this one's 4.5 and this one's 3.0. Now, do we know how big this side is? Yes, because if the entire length of this segment is 8.4 and we're looking for half of it, that means this one is going to be 4.2. If you look closely, none of these line segments have equal lengths. Therefore, we have a scalene triangle. Okay, we've got one last problem before we finish up with 4-1. If point C is the midpoint of BD, classify triangle ABC as equilateral, isosceles, or scalene. Now, if we take a look at this triangle, C is the midpoint. Once again, we're going to bisect this line segment. That means these two are going to be congruent to these two over here. BC is congruent to CD, and if we take half of 3.4, that's going to give us 1.7. Now, since this is 1.2, that means this one will also be 1.2. The line segment AC is 1.2. And if we look closely at triangle ABC, since two of these lengths are congruent to each other, it will be, I'm just going to highlight it, an isosceles triangle. Ladies and gentlemen, boys and girls, that's the end of 4-1. If you have any questions, no, I'm going to keep that. If you have any questions, go down to room A134 and ask Mrs. Jennison, or A127 and ask Ms. Robbins. Don't ask me anything because I'm going on strike.